Greetings, students. Today we're going to be looking at the history of computers. We have a special guest here. I'll be asking him what's his take, how does he feel about information technology. Well, please respond.
This one I do with the jabata. Me, I no get time, I did that, da. Dada cover my face, calling me like Baja.
Today we'll be looking at the history of computers. Please bear in mind, even though they are called computers, these devices did not use electricity. They were what we call mechanical or manual machines, meaning someone had to be cranking it, turning a lever in order to get it to work. Alright, so let's go. Initially, calculations were used mostly by merchants and so on, and they needed to add, subtract, multiply, divide quickly. Now, this was the time before electricity and before any of the modern day devices were invented, but people still calculated in those days. How? They used the abacus. And there's a picture of the abacus. There's more than one type of abacus. This one is a wooden one. It's not as advanced, but it's still, they use it in basic school to teach students, children, how to count. Alright, let's go. So an abacus is a frame which holds a series of wires or rods with beads on them. Some early abacuses did not have wires and the user just moved beads or stones on the abacus, shape drawn on a board. The abacus is used to count rapidly and to add up and subtract. The beads are slid up and down rapidly as the user counts, or it can be slid to left to right as well, by the way. Abacus were particularly useful for merchants dealing with money calculations. Here's another example of an abacus. Please notice that they are using beads, look like some form of seeds. And this one is a wooden one. If you watch those old Chinese movies, you will see them being used in the old Chinese movies. The abacus was invented at least 5,000 years ago. Alright, that's what the book says. I think it's much, much more than that. I think it wasn't only limited to Egypt and Central Asia. I think it was being used all over the world. That's what I think. Even though it said it spread through Asia, Africa, and Europe, I think it was already being used all over the world. I don't think it really started in Egypt. It's like saying all computers started one place. No, everybody was developing their own computers. It's not practical. Anyway, a skilled abacus operator was a respected professional in ancient times. Now let's look at our second mechanical calculator. A French philosopher and inventor called Blaise Pascal. It's French. He invented a mechanical calculator in the 17th century. He was only 19 years old when he invented it. He wanted to help his father, whose job was to collect taxes. Pascal's calculator is sometimes called the Pascalina. Alright, and here we have an example of the Pascalina. This one is wooden, it's a wooden Pascalina. This one is metal. I remember in those days there weren't as many stores. You couldn't just walk into a store and buy what you wanted. Anything you wanted, you had to hire somebody to make it for you. So Pascal's calculator had little gear wheels inside. To enter a number, you dial it in, a bit like dialing an old phone. And remember the old phone, the rotary phones? I'll find one and put it in for you. Okay, so you would dial in these numbers and then it will tell you the answer up top. All right, and people used to hire him to make them for him, but it would be like kings nobles and so on who could afford that. A few years later, Gottfried Leibniz from Germany invented a competing design called the stepped reckoner, which could perform addition, subtraction, multiplication, and division. So you see, everybody is developing their own calculator. So there's no such thing as one person making or inventing something. Knowledge is shared. These inventions were very cleverly made, but they were expensive and were not widely used. Like I said, mostly nobles and those rich people, kings and queens would use them. Now let's look at Babbage's engines. Early calculators worked manually, meaning somebody had to turn something for them to work. But in the 19th century, a man in the UK called William Babbage invented a type of calculator which would work by steam power. Okay, so we're stepping up now. It worked by what? Steam power. Okay. His plan was that his calculating engine and his later invention, the analytical machine, would carry out calculations very quickly using stored instructions. So here's an example of the Babbage. It looks like a closet to me. I don't know. Here's the man spinning. It's mechanical, which means he's turning something. He's spinning to get the machine to do the calculation. Babbage was never fully able to build the machines he invented. Technology was not quite advanced enough. But nowadays, looking at his designs, we can see that he invented many of the key functions of a modern day computer. For instance, his engines had input output storage and processing. Babbage was a friend of Ada Lovelace, a woman who was a very good mathematician. She invented the first computer programs to run on the analytical machine. If it had been built, she would have been the first computer programmer. There is a modern programming language called Ada in her honor. Now the way I remember it is I look at Hollerith as a desk. I look at Babbage as like a closet. Notice the crank on the side right there. So they're going to crank it, to turn the machine. Okay. So now we're looking at the Hollerith tabulating machine. In the 19th century, the US government had a problem. Every 10 years, they did a census. They gathered and counted information about all the people who lived in America, but it took 8 years to count them up. The answers from the census in the 1980 and population was growing so fast that they were worried that the next census would take even longer. Soon the counting might take more than 10 years because remember the population is growing. So when the population is growing, that means that's going to take longer and longer to count. And why do they take censuses? Because in order to know how much police to hire, how many fire stations to build, how much roads they're going to need. Plus, when they borrow money based on the population. So when they borrow money from the IMF or the World Bank, the more people they have, the more money they can get because it's the people they use to pay back their bills, their debts. So that is why they do the census. It's not just for the information, it's also to enable them to borrow more money. Okay, so soon counting might take 10 years or more than 10 years, which meant they would not finish one census before it was time for the next. So, in 1989, an American called Herman Hollerith invented an electrical tabulating machine that would count the census. Okay, so this one is electrical. Now we're getting into the electrical stuff. Now notice the lady here. She's punching the papers, and what they do is they punch the papers in such a way, so that the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can count the holes. So in this position, the machine can cou This would be two persons living in a house. This would be three persons living in a house. This would be four persons living in a house. And the machine would add them up and give the result. Okay. So operators punch holes in the cards to represent the data from the sensors. Algorithm machines read the cards and added up the numbers of holes it took. Using this machine, it took only what? 1 year to count the results of the census. And here we can see a picture of the Hollerith machine. Here's the paper with the holes that the machine is going to count. Hollerith formed a company which made tabulating machines for businesses to use. This company eventually took the name IBM. IBM stands for Integrated Business Machines, and they're very popular nowadays, and went on to build some of the first commercial computers. If you wanted to change the way a Hollerith machine looked, you had to take it to pieces and rebuild it. In the decades that followed, true computers were developed. Unlike the calculating devices and machines which had come before, computers could be programmed. That meant you could enter instructions into the computer to make it carry out different tasks. So in those days, those machines, they could only add, subtract, divide, multiply. But nowadays, modern computers are more sophisticated. Computers have developed through many generations since they were first invented. Each generation of computer is smaller, faster, and more powerful than the computers that came before them. And those are the five generations of computers. I trust you learned something. Please spend the time, sit quietly, let the knowledge soak into your brain. Watch it again if you need to. If you don't like to hear my voice because I put you to sleep, please go and read the paper notes. Let your brain absorb it because the test is forwarding next week and I want you prepared for it. Until next time, good reading.